This is the single trunk tree demonstration. We will first initialize this executable program. First, for the range, we will input 1000 units. For the number of terminals, there will be 1000 of them. Now we will randomly generate these terminals. Then we will click on 1, which gives us a single trunk that connects all of these terminals to this trunk. Let's look at a complicated version of the single trunk tree. First, we will input the range at 1000 units. For the number of terminals, we will increase it to 10,000. Now we will generate these random terminals. Then we will click on 1 to show the result of the single trunk tree. We can see that there are too many terminal lines. The disadvantage for this tree structure is that the lengths are too long, and that to reduce this, a new concept called cross trunk is introduced, where it uses vertical and horizontal axes. This is a cross trunk tree demonstration. For the range, we will input 1000 units. For the number of terminals, we will input 1000. Now we will randomly generate these terminals. To find the cross trunk, for the vertical trunk, we will use the terminals x-axis average. For the horizontal, we will use the terminals y-axis average. Then now we will find the cross trunk by clicking on 10. Now let's look at a complicated version of the cross trunk tree. Here for the range, we will keep it at 1000 units. For the number of terminals, we will increase it to 10,000. Now we will randomly generate these terminals. Then we will click on 10 to produce the cross trunk tree. The disadvantage of this is that there are still too many terminal lines. Compared to the single trunk tree, we can see that there are some improvements. Therefore, a new concept called refined single trunk tree is introduced. This is a refined single trunk tree demonstration. For the range, we will input 1000 units. For the number of terminals, it would be 1000. Now we will randomly generate these terminals. Then we will click on RST to produce the refined single tree trunk. The terminals are connected through a bridge to the branch. The branch is connected to a trunk. Now let's look at a complicated version of the refined single trunk tree. For the range, we will continue using 1000 units. For the number of terminals, we will increase it to 10,000. Now we will randomly generate these terminals. Then we will click on RST to perform Refine Single Tree Trunk. This is the result. When comparing this to the previous two methods introduced, this method has improved a lot. But when we look at an example, in this particular area, there are too many bridge connections. Therefore, a new method called H-tree can help solve this problem. This is the H-tree demonstration with no obstacles. For the range, we will use 1000 units. For the number of terminals, we will use 1000. Now we will randomly generate these terminals. Now we will construct an H-tree. The H-tree is based on the number of terminals. Now we will link the H-tree. For the last part, we will trim the excessive H-tree. Let's look at the H-tree with no obstacles on a complicated case. For the range, let's set it at 1000 units. For the number of terminals, we will increase it to 10,000. Now we will randomly generate these terminals. Now we will create an H-tree. Now we will link the H-trees. Then we will trim the excessive H-tree. The length of the wires have been reduced. Therefore, our proposed method can be more practical, thus allowing us to perform H-tree with obstacles.